Hello everyone! This is going to be the solutions to FRQ number 2 for the AP Chemistry 2022 exam. And without further ado, let's just go ahead and get started. You can access these questions in the link in the description box down below, or you can use the link in the video shown right now to access the PDF file. And just another quick reminder that this is not affiliated with the AP College Board in any way, shape, or form. This is simply just a video discussing over the answers to the FRQ. Okay, and beginning with question 2a, we've got a reaction between methanol that forms carbon monoxide and hydrogen gas. This first question asks us if hydrogen is being reduced or oxidized in the forward reaction. So I've enlarged the equation, and for each element, we can go ahead and write down oxidation numbers. Since it's just asking for hydrogen, and hydrogen is a positive one charge in a compound, then we can go ahead and put that down. And for hydrogen in its elemental form, it's going to have an oxidation number of 0. And this goes for all elements in elemental form. Now we must look at the change in the charge. So hydrogen goes from a positive 1 charge to a 0 charge. And so because it goes from positive 1 to 0, hydrogen is actually gaining an electron, which means that hydrogen will be reduced because it's gaining. Again, everything with the whole oxidation and reduction thing, it's always the opposite. Okay, and next up for question 2b, we have to draw a Lewis dot diagram, assuming that carbon and oxygen obey the octet rule. Okay, so if we look at the periodic table, which is given, carbon has 4 valence electrons and oxygen has 6 valence electrons. And so I'm going to enlarge the C and the O, and I'm going to place the 4 valence electrons around the carbon and then the 6 around the oxygen. And so looking at this model, the carbon and oxygen needs to have a triple bond in order to gain that stability, which leaves two valence electrons on both sides, on both the carbon and the oxygen. And so if we count up all the electrons, carbon has 2, 4, 6, 8 electrons, and so does oxygen. So we are good on that. Now for question 2c, we're given each of these substances and their molar entropies. And now we're asked to calculate delta S. So if you'll recall, the formula for finding delta S is the summation of the S values on the product side minus the summation of S values on the reactant side. Looking back at the chemical equation, we can go ahead and fill out each of those values. So for methanol, it's going to be 240. For carbon monoxide, it's 198. And for hydrogen, it has 131. So now we have to add the values on the product side and subtract the values on the reactant side. That's going to be 198 plus 131. And remember that there are 2 moles of the hydrogen gas, so you actually have to multiply the 131 by 2. And then you want to subtract that quantity from 240, which is on the reactant side, and you get a value of about 220 joules divided by Kelvin times mole of reaction for a final answer. Next up is the second part to 2c, and we have to calculate delta G of the reaction. Because we're given delta H and delta S, then obviously the equation we should use is delta G is equal to delta H minus T, which is temperature, multiplied by delta S. So for delta H, we were already given that in the problem, and that is the 90 kilojoules divided by mole of reaction. So we can go ahead and plug that into the equation. And then for T, or temperature, that's going to be the 375 Kelvin. And again, we were already given that. And now for delta S. Well, for delta S, we already solved that in the first part of 2c. And we got a value of 220 joules divided by Kelvin times mole of reaction. But if you look at the units, the delta S that we just barely found is in joules, but it's asking for delta G in kilojoules. This means that we must do a unit conversion. So I can start off with the 220 joules, and I'm going to divide that by 1,000 joules because there are 1,000 joules in a kilojoule. And if you plug that in to your calculator, you get 0.22 kilojoules. And now that we have the same units, kilojoules, we can plug that into our equation. And now go ahead and plug all of this into your calculator, and you get 7.5 kilojoules divided by mole of reaction as a final answer. Now for question 2D, we're given a particle level diagram of the chemical reaction. And so it's actually asking us about partial pressure. So the first thing to note off that this is an equilibrium. And so we can use the partial pressure equation for this. And that's going to be the partial pressure of one gas, which in this case we're trying to find the partial pressure of carbon monoxide. And that's going to be equal to the total partial pressure multiplied by that by the mole fraction, which is equal to moles of A, or carbon monoxide in this case. Divide that by the total number of moles. And also just a quick note that this equation is on your AP Chemistry reference sheet, so you don't have to memorize this, which is really nice. Okay, and now let's go ahead and find the mole fraction for each element. So for the methanol, that's going to be 1 out of 10. And so if you look at the diagram, it's 1 out of 10 because there is 1 mole of methanol out of the 10 moles. And then for carbon monoxide, it's going to be 3 out of 10 because there are 3 moles in the diagram. And for hydrogen gas, it's a 6 out of 10 because, again, there are 6 moles displayed in the diagram out of the 10 moles. And because we're asked to find the partial pressure of the carbon monoxide, this is the number we want to use, the 3 out of 10. So take the 3 over 10 and multiply it by the total partial pressure, which is 12 atm, and you get a final partial pressure of 3.6 atm. Okay, so yeah, again, take the 3 over 10 and then multiply that by the total pressure, which is 12 atm, and you get 3.6 atm as the partial pressure of carbon monoxide. Okay, and then for question 2E, it wants the equilibrium for the expression for the equilibrium constant. And note that this is going to be a Kp value, which deals with partial pressures, and partial pressures always deal with gases. So I'm actually going to put up the chemical equation for reference. And let's just start writing the expression, which is products over reactants, of course. So our Kp is going to be the partial pressure of hydrogen, and we're going to square that because it has a coefficient of 2. And we're going to multiply that by the partial pressure of carbon monoxide, which is a product, again, products over reactants, and that's going to be divided by the partial pressure of methanol. And so it looks like in this problem it doesn't ask for any values, so I guess this is the final answer. Not too bad of a problem, if you ask me. Okay, and then for question 2F, however, it does provide partial pressure values, which means we do have to plug it into our equation, which honestly isn't even that hard, but I mean, that's okay. We like that. So it's asking us, again, to use that same equation from part E and just plug in values. So this was our equation from question 2E, and here is the table for reference. And so just plug in the values wherever it goes. So if you plug all of that in, you get a total partial pressure of about 110. And since everything's in 2 sig figs, let's just go ahead and do 2 sig figs for fun. So let's bring that to 1.1 times 10 to the second power. And again, remember that the equilibrium constant is unitless, so it's not going to have any units, so just put that number down and you're good to go. Okay, and finally, we are on our last FRQ, which is 2G. And this focuses a lot on Le Chatelier's law. So it states that the volume of the container is doubled, and if the number of moles of methanol will increase, decrease, or remain constant. And then also given all this information, we have to support our answer with Q and K. So when they mentioned that the volume of the container is doubled, then you'll also notice that according to Le Chatelier's law, as volume increases, pressure will decrease because they're inversely related. And this means that it must shift to the side with the greater gas moles to reestablish that equilibrium. So we have to go to the side with the greater gas moles. So on the reactant side, there's just 1 mole, as shown there. And on the product side, there are actually 3 moles. The product side has more, so it must shift to the side, of course, because it has more moles. And since we have to justify this using Q and K, well then Q must be less than K, because since there is less product and more reactant, it must shift to the product side, which will eventually bring it back to equilibrium. While doing that, since methanol is a reactant, it will eventually decrease while the equation is shifting to the product side, and that's going to be our answer. And yeah, I think I'm pretty much done with all of these FRQs, which is awesome. And just a quick reminder, I kind of talked about it in my first video, but these are the score predictions, and these are not the official score predictions. These are just like my own predictions of what it might be this year, based on past years. And I talked more about like the scoring and stuff in my last video, so if you guys want to check that out, don't be afraid to, and I'll link that in the description box down below as well. And then here are the score predictions for a 4 or a 5. And then also here are last year's score statistics, just to kind of have a reference of how AP College Board does their bell curve. And yeah, thanks for watching. Make sure to subscribe for more videos like this one. I'll be posting some more answers to the last 5 FRQs pretty soon. And I'll also do the same for the BC Calculus FRQs this year. And I also have some fun special videos coming up, such as ACT prep and how to conduct research in high school. So be sure to stick around for that. Make sure to subscribe, hit on post notifications, of course, and give this video a huge thumbs up. And bye, everyone. Have a fabulous day.